feel free to ask at any time. But right now we are going to look at working with game states and fitting that into the project. So beginning with this, what we do with the game state is we're able to keep track of the state of our program. What is our program currently doing? And a simple way to build this state machine is to store that game state in a variable. Now, in some programming languages, we have a type of variable called a constant. A constant is a value that has specific, so it's fixed, so we can set and assign it, so we can create constants that would be used with our game state. Processing does support constants, but it's a little more complex to incorporate those. But we will create that same representation of using a constant by using the programming convention of naming it in all capital letters. So when we do that, that tells us these are kind of fixed values. Now, we're going to use a string to store the game state. So we have a string variable called game state. And as the comment points out, the possible states for our game currently are start, play, win, lose, and reset. So these will be specific options that we are looking for in our game. So then we can initialize the game state with our starting value of start. We've also assigned values to our other variables that we'll be using when we begin on this game. The nice part about using a game state is it helps us to further organize our code. So when we went with our code and we started using functions as a way to group similar lines of instructions together, so it helped to organize our code, we look at game state, draw suddenly has become a much cleaner, simpler thing. It's a basic conditional that cycles through the various possible options for game state. So if game state is start, it calls our start state function. If it's play, it calls start state play. If it's win, state lose, state reset. And finally, if something has happened in our state system and it is broken down, it's going to print out this line if something went wrong with game state. So that's a real simple way of doing error checking, where we're keeping track of, hey, if something breaks, then it's going to print out this message. So our draw function is done. We don't have to do anything else with it. Now, one thing to realize is we're going to roll forward with this as we go through and build more and more complex programs. By organizing our code like this, we start to have structures and systems that we can then reuse from project to project. Because realistically, all I have to do is just swap out what's happening within each of these state functions that's coming up. If my game gets more complex, then I add more stuff into my play function. If my game needs more stuff to happen at the beginning, well, then I put it in there for my win, my lose, etc. But I can reuse the same structure in subsequent projects. So I don't have to now start over going forward. I can just use this as a template, as a beginning place to create my project. Now we can see reset's not doing anything yet. Reset is just going to reset things and roll with it. Now, running my game right now, it's going to create a blue background, and then it's going to draw a white circle in the middle of the screen. Now that circle is going to be my start button. So if I want to turn this into a button, I have to figure out how to detect when the user has clicked, not in the blue, but in the white area. To figure out that I clicked on the button, the first thing that I want to do is to find out So I'll just say if mouse pressed, and I'm just going to start out with that first. We could write this into a more complex conditional, and we will. But right now, if mouse pressed, what I'm going to do is just simply say background. I'm just going to change the background color real quick. And you can see when I press the mouse, so we have a mouse pressed event that we can check. So if I press the mouse, we can see that something's happening. And when we're developing our code, it's really useful to just do stupid basic things like this where I change the background. And notice the button went away when I did that because my background isn't a filled rectangle, but it said, hey, wipe the background with red. So as long as I was pressing the mouse, it kept wiping the background with red. So we just do something really simple first when we're programming, and then we add more to it. We should never try to do everything in one shot because it'll break. It won't work. And then you'll be crying and unhappy, and there'll be lots of sadness in the universe, and there's enough sadness in the universe we don't need to add to it. So we proved that we can do that. Now we need to find out, hey, can we get to knowing is the mouse over where that circle is? Recycling something from a previous lesson where we have two objects and we can find out when those objects are intersecting, or when the distance between the point of where my cursor is, and I'm giving it a big distance, and this other object, we see that what we have is we have the ability to calculate the distance between 2 points. So we can calculate the distance between 2 points. So knowing that we can use that kind of knowledge gives us the ability to find out, is the mouse, when it's being pressed, inside that circle. So what I want to know is the distance between the mouse X, mouse Y, so between, oh, that's spelled funny, and the center of that circle, because, and this is part of why I chose to do a round button, because then we can continue with our circle-based collision methods. So the center point of that button, which happens to be at 400 and 300. So if that distance is less than, and this is where we need that radius value, so that half of the circle, and we know that this button is 100 pixels wide and 100 pixels tall, so it has a radius then of 50. So if that is the case, and we'll just move that over, then, so now I want to only change the background color when the distance between the mouse and the center of that circle is less than 50, which means I am over the button. So I click out here, nothing, go into the circle, and I can click anywhere in that circle, but as soon as I'm outside that circle, it doesn't work. So you can see it's based on where is my mouse pointer when it turns red. We want to change the cursor so it behaves in such a way that it gives us the visual feedback of becoming a hand when it's over the button and not a hand when it's not over the button. We may want to package these a little bit different, and instead of changing the background and burying this inside the mouse pressed, if it's outside of mouse pressed, while we're working with it. So when this is the case, well, we can make that. We can change the cursor to hand. So if the distance between the mouse and this point is less than 50, the cursor becomes a hand. Else, the cursor becomes an arrow. Now when we do that, we can see how it's working. It's also changing the background color, which I just commented out, so we can see how the hand changes. So what we want is, when we have rolled over this, and while we're over that, inside that if statement is where we really care about doing something with the mouse pressed. So I'll change the background color at that point. So now when it runs, we can see if I roll over this, we get the cool effect. Roll out, I get back to the arrow. And then when I press the mouse, it's doing something. Change our button color. I'm going to change it to yellow. So if I change my fill, oh, wait. It's kind of working, not quite. So if I change the fill color, then I just need to redraw the button at that point. So we can see now gives that visual effect of rolling over, so it's highlighting like a button, and the cursor is changing. Now, this is working nice. We're making kind of a cool little button. We have the button behaving. What'd be better is if when I roll over the button that I can change my game state. So while I roll over the button, what I want to have happen, instead of just changing the background color to red, I'm just going to leave that there for kicks, and you'll see why I don't mind that. If I change my background state, or my game state to play, now when I click on the button, we have a duck that is updating and displaying. Right now, to build in playability into the game, right now the duck is wandering off the screen, not doing a whole lot. The easy one to keep track of here is to find out, has the duck gone off screen? If the duck goes off the screen, that means we have lost the game. So our lose option is going to be if the duck's x is greater than or equal to the width of our game. Couple curly braces, go up an arrow. So if that duck's x has gone off screen at that point, we want to change our game state to lose. Once again, don't try to put in the win as well. One thing at a time. A good practice whenever you're coding, add one option, test your code. Add something else, test your code. Add something else. But don't add 10 or 20 things, test your code, it breaks, and now you have to go figure out which of those 10 or 20 items is causing it to fail. So I got my cool button here. I don't have instructions on screen, so I may want to put some instructions on the starting screen to tell me what the rules of the game are, but we'll get back to that. Now we'll let the duck wander off screen. We'll also notice my cursor is still a hand. Oh, and if I look through my game states, game state lose gives me a red background. Game state win will give me a green background. So I'll be able to very easily tell that is what's happening. Knowing that now, we also saw that the cursor stayed a hand. I'll run it again, click the button, the cursor is now still a hand. Now maybe we want the cursor to be a hand when it goes over the duck, but we don't necessarily want the cursor to be a hand at all times. Starting state, a little housekeeping, I could just simply say cursor, arrow. And now that guarantees that when I leave, back to the arrow. But if I want it to turn to a hand over the duck, then I can incorporate that in. So we have a lose option. It seems to be working pretty well. Time to work on winning. You will notice that, again, our draw function has been cleaned up. So our draw isn't trying to handle starting stuff, playing stuff, winning and losing. It just changes and manages our state. That is going to be a much better structure to work with, is to have the draw function manage the state, and then I have each of my states in their own methods. To incorporate winning into the project, we need to figure out when we have clicked on our set object. Now this is much like using what we have in the catcher game, but instead of having intersection into its own function that we're passing into it, which we do need for that, we have it hard-coded in here. Now if I look at this, if the distance, because this will work with one object, but if we want to work with an array of objects, that's where we ideally use that separate intersect function as part of our program. But we can start out and add in pieces where we can find out, hey, have I overlapped the duck? If so, change my cursor to a hand. And we're also going to find some limitations using circle-based collision at this point. Because the duck, I do have a rectangle that sits in the background that shows us kind of where that duck exists on screen. So working with that kind of option. So if the distance of the mouse x, mouse y, and this is going to be then the duck's x and the duck's y, is less than. Now the duck is drawn into a 100 by 100 pixel square. So the radius for the duck is approximately 50. The duck is not a perfect circle. It kind of fits more into a rectangle, but we can put in 50. So if that distance amount, if that is where we are at, then if mouse pressed, at this point, just going to change my background once more as a way of proving that this is working. So we're using that same distance between 2 points. If the distance between those 2 points is less than 50, that tells us that our objects have overlap. Now if I run this, So we can see it's working. Now, what I am also going to do is just do the cursor hand while I roll over it. And then do the, go back to the arrow option as well. And in doing that, that gives us that visual feedback. So we can see where, when I'm over the duck, we can see I could also click above its head. Oh, and the game lost. It went to red. So we knew our game state went to fail because the duck ran off screen. So, proves it works. The better option would be to change our game state to win. Now if I click on the duck, I'm clicking around, nothing, roll over it, give the hand, good, click, and now we're on the win state. Oh, and the win state still draws a button. Forgot that was still in the code. One of the things that would be nice in the game is to provide some insight or instructions to the player. That probably should take place inside of our start state here, where we put some text on screen. Now, writing text on screen is fairly straightforward. We use a text command. We're going to list what text we want to put on screen, and then we get to say where we want that text to appear on screen. There are a couple of things we will want to pay attention to with it when we put the text on screen so that it formats itself nicely. But I could just start out with saying click to play and then figuring out where to put this on screen. If I look at the help text where it's giving me an error at the bottom, it says, well, text expects parameters like string float float. That float float are the x and y of where we want the text to be. My x of where I want it to be, I want it to be centered at 400. And then I want to figure out where the y, well, if the y center is 300, 50 above that is where the top of the button is, so we need to go either above or below. So I'm going to put this text below the button, and we'll put some instructions about the pointer, objective, or rules of the game above it. So to put this text below the button, we need to be below 350. So I could say something like 375 as an option, and we'll see how that looks. Now when I run it, we'll see it puts some text underneath the button. It's the same color as the button. I want to color it, I need to change the fill, but my text is not centered. In the reference, we'll see that we have certain options, of which one of those that I can choose would be text size. I may wish to make my text a little bit bigger. If I want to do that, I can see I can enter in a size in pixels, but also under text we have text align, and under text align we have options of left, right, center. So if I use text align, and then I can specify where I want my text to be aligned on the screen. So going back into my project here, text align, center. Now if I run it, we should see that the text is centered at that point. Perfect. The next thing that I can do is give myself a text size, and now specify a size in pixels. I'm going to choose 18, and we'll see the text got a little bit bigger. I have my base text going on for my instructions. If I want the text, or for my click to play, if I want some text to show up on screen that tells me to how to play, or even to name. So if I were to do a text size, let's say 36, and then I could do text duck hunt, It's not a very exciting duck hunt yet, but it's the start. And I'll put it at the centered X value of 400 and do a Y value of 200. Now if I run it, we'll see. I think I need to put it a little higher so I can put instructions underneath duck hunt. So we'll have to go up a little higher. Instead of 200, I'll go at 150. And now I can just do a text size. This time I'll put it down to 14, so it's smaller. This will be my instructions. Shoot the duck. Do not let it escape. And this again will be X of 400 and the Y, we could try 200 for that and see how that looks. So now we have a title, we have instructions, we have our button occurring on screen. Notice we have an interesting conundrum happening here. So because the fill color never gets reset back to white after I draw the ellipse and fill it with yellow for the rollover effect, that yellow color is then the current fill color, so then when I draw text it uses that as an option. A good practice would be to set the fill color before I draw any text, so now it's not affected by the button. On screen we need to declare the color, the alignment, the size, and then what the text is and where we want to draw it. That's all it takes to put words on screen. So the color, alignment, size, and then where we want, what we want to draw or say, and where we want to say it. Going back into my game here, I want to put the score on screen somewhere. So if I were to say something like text score and then declare where, I'll say let's put it at 50 and 50. See what happens when I run this. And we'll see my text is showing up in the color orange. But if I look in my play state, nowhere have I used the color orange. We'll see that the last color used was the orange color to fill the triangle. So if I draw the duck on screen, that's the last time I specified a fill color. Therefore, my text is showing up in that same color. So it's always a good practice to set the color designation for your text. I'm going to reset my alignment so I know it's where I want it to be. So we can see now it's showing up correctly on screen in the color I want it to appear. Again, color, alignment. Now the size, it's still remembering the 18-point size back from my start state. So if I wanted a different size, I should put that in. And it would just be a good practice. So if I want to go a little smaller, I want to go down to 14. To specify. So every time we put text in, it's a good practice so you don't have unexpected events occur. Color, alignment, size, in addition to the words you want to have show up on screen and where you want them to show up. Tracking the duck clicks, we will put that into our score value. So to do that, we're going to modify what happens when I click on it. Instead of just immediately changing the game state to win, instead, we'll come back to that line, we'll reuse it later. What I want is my score to go up by 1. So I could do plus equals 1, or because it's just going up by 1, I can just simply say plus plus. That will now increase my score if I press the mouse. Now an interesting thing will happen with this, because the game is resetting at 60 frames per second. While I'm pressing the mouse, it's probably going to register, by the time I click the mouse and let go, multiple frames happening, unless I can get that click of the mouse to be super, 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 super fast. So if I click here, we can see just a simple click goes up by almost 5 each time. So that doesn't work to just simply have my score go up, but instead what I need to do is to reset my duck. This is much like in the catcher game where the drop falls. When the drop hits the bottom of the screen, it resets itself to the top of the screen. Well, here I want to reset my duck to a new random Y position, and I will set the X. At this point, I'll just put my X at 0 so it starts off the screen. So I'll just copy that to speed things up. So X will be 0, Y will be a new random amount. So this duck doesn't keep going in the same line. It could, so each time it resets, it's going to go into a new place. And then I can just say, tell my duck to reset itself. So the reset method inside the duck knows how to update itself, it knows how to display itself, and it knows now how to reset itself. This is all the duck needs to do. Otherwise, our duck is a pretty dumb object. It doesn't need to do thinking. When you have class objects, the objects themselves shouldn't normally, in most cases, think about other objects. They should only be aware of their own existence. Your main program gets to then determine the interaction between objects, but one object shouldn't really know of or care about another object. Objects should exist in their own closed universe. So now when I click, I can see the duck reset, score 1. Hey, look, there's a score of 2. Hey, a score of 3, and each time it's going to a new place.
I think every time you click it, it should get faster.
Difficulty, we can say speed X is going to, every time it resets, it's going to go a little bit faster. So speed X is going to then be equal to, or we're going to speed X plus a certain amount, and in this case we'll just add 2, so it's not super crazy.
There we go.
Oh, I missed. Okay, that adds in. That makes it harder. So it's gotten a little bit harder to play. So if we look at what's going on, we check to see, is the cursor over the duck? If the cursor is over the duck, if I press the mouse, meaning I've clicked on that object, then our score goes up. And then we reset the duck so we don't keep getting scores while we're on top of it. At this point down here, we would maybe want to say if score is greater than or equal to 3. No, let's go 5 because that makes it a little bit harder. So if that's the case, then I can now say my game state is going to be equal to. So let's see, can I do it? 1, 2, 3, 4, 5. Hey, and now I won. Is now increased in the game. Hitting it 5 times while the duck is accelerating itself each time makes it significantly more challenging, so that's kind of fun. build some excitement into the game. The final thing that we need to be looking at is once I've won or once I've lost, how do I go about resetting my game and do something with it? To that end, what we're going to do is go back to our starting state and borrow a lot of information from that. So what I'm going to do is I'm going to copy everything inside of my starting state. I'm going to copy that and I'm going to paste that into, I'll just do the win state for now. But now with the win state, we'll change the background color to green. So if I win, it goes green. But this time, what I want to have happen is I don't want it to just simply say click to play, but I will change it to play again. Can put in some congratulatory text. Great job. Shooting. No, it wasn't really shooting. Eventually our duck hunt will be shooting, but this one is just clicking. Getting, yeah, we'll just leave it as great job.
You can put the score.
So I'm updating the text inside of my win state. Everything else is virtually the same here. And before I worry about the lose state, I'm going to go attempt to win the game again. And we'll see if this works. Oh, and under play again, I want that to be a question. So now, running the game. Click. 1, 2, 3, 4, 4. Oh. And I won. Whew, that was stressful. That was hard. But now I can see green got the text. Probably not the best color relationship. We'll have to rethink that. And if I click on it, wait, I'm still winning.
What did we do to make it?
At this point, it becomes apparent we have some issues. The duck resets. I won, great job. If I click here, oh wait.
Because we never reset it. Never did.
So the game is still running because we have a few things some housekeeping issues that we need to take care of. And this is why we have this additional reset state that we want to work with. So instead of, after we've won, instead of changing our game state to play, what would be a better option is to change our game state to reset, and under reset we take care of some housekeeping issues. Namely, we need to update a few things in the game. The reason that our game is still continuing to loop, I'm going to see if I can get it to show up on screen. So we'll look up in the top left corner, we'll see that the score is still 5. So because the score is 5, our game thinks we've won. So one of the things that we need to take care of, we need to reset our score back to 0. Now when I do that, then I can say game state is equal to play. So that now resets the score. So when I win the game, I'll change my, if I press the play again button, I will change my game state to reset. And under reset, I am going to set my score to 0 and then update my game state to play. And the reason that this has been separated out is we'll find that our win state and lose state are going to be very similar, but we'll draw different backgrounds, we'll have some different text. But all of this resetting behavior is the same. So it doesn't make sense to have it in both places identical and the same. Running my program once more. 1, 2, 3, 4, 5. There it is. Now I can click and say, whoa!
Yeah,
Wait.
reset the speed.
Yeah.
But Mr. Duck is still hauling
Hauling
across
what?
the screen.
That could
He's
be
hauling duck.
That could be level.
Hauling duck, and it's time to reset the duck's speed. So with that, we can do it in a couple of different ways. I could hard code the value in, but he's not called duck, he's D. And we need a different, because we already used reset, and now it's telling me reset game doesn't exist, but I know that. We already used reset to reset the duck when it hits to the edge of the screen after it's been clicked on. So now we need a different method to use. So this will be when we're resetting for the game. And with that, we'll reset the duck's speed. The initial speed for the duck was 2. So we can reset the speed x equal to 2. We could also choose a random value. I could go anywhere from 2 to 4. So sometimes the ducks, when we start the game over, maybe they're going a little bit faster, or maybe not. Maybe 2 to 3, so it's just a small variability. We could make that the norm, that the duck, every time it resets itself, it could be a random value as well. So there's a lot of flexibility, but I'll just leave that there at the moment. And now when I restart it, I'm going to just leave it though fixed at, I'll do a fixed 2 just so it's easier to tell that the game is indeed working. So click 1, 2, 3, 4, 5. Click, hey look, the duck slowed down. Now pay attention to, so the duck, the last time I stopped the duck, he was right here near the edge of the screen. If I start the game over, okay, good, now the duck is resetting at the edge of the screen. So it does appear our game is functioning. Minor technicality is when it's set up, if it resets itself as soon as it gets past the width, the problem it runs into is it resets its position before we're able to register that it went off screen, so then we can't lose, and that happens if we're using random speeds such as 4, because that means with the speed of 2, the math worked itself out that it would always land itself right at the edge, so then it could detect it. But by, say, 3 or 4, the way it's jumping, it's not able to register that. So it's just the unfortunate kind of ratio of the math and adding up the frames. But if we just put the reset further, and I'd say, yeah, let's just go further off screen before we reset ourselves on screen. And that also means the duck fully disappears from view, and then that's totally believable. So if we watch the duck, it's going to fully, oh wait, we have to win. Yeah. It will fully go over before it resets, so that guarantees we should lose. Or not. Shouldn't be with minus 100, should be with plus 100. That's why it's disappearing before it gets to the edge. So no, we want to disappear after we've crossed the edge. So now we get to watch the duck move, 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 and now it's able to go far enough over. And if we want to go further, then we could go further with it. But that now means the duck hit the edge and then it ended. Item to work in here is to mimic what we did, not mimic, but pretty much clone what we did with the win state. But this time we're going to do it with the lose state. So I'm going to copy the win state, paste that into the lose state, The lose state, though, I want my background color to be red, so it's hostile. We can leave the button information there, and then say, horrible job. You were beat by a silly duck. Play again. Now you will notice that the win state and lose state are very similar to each other. And that also tells us that potentially there would be an optimization we could make in the code where we could have one kind of conclusion state that we pass to it a value. Did we win or did we lose? And work with it. But for the meantime, we will live with the redundancies in code for now, because we do have a different background we're drawing, and we have different text we're showing up on screen. So we will work with that. Put the extra 0 up there under lose. So now if we let the duck wander itself off screen. All right, I lost, horrible job. I was beaten by a silly duck. Play again. And now we need to take care of a few things, apparently. So when I click, we can see the duck is still trapped on the right side of the screen, and eventually it gets far enough over that now it gets to start over. So when the duck resets itself, we need to reset some other values as well. If you're concerned about repetition of code, you certainly could work on coming up with some optimizations of how you might go about doing this. You might have one reset position function, and then the reset and reset game reset, update the speed appropriately, and then just call that reset position. That would be another option. Adding in more functions so that you're not duplicating code is a good practice to get into. Now if I run this and lose the game, I will be able to reset properly. And now it resets. And that time the duck apparently got a little faster than 2, because I'll be between 2 and 4 as my starting value. So it's going to vary each time I play, so there's a little bit of randomness built into the game. Now I have a complete program. Using game states, we're able to manage our start, play, win, lose, and reset states. We can handle when our state goes wrong. Each one of our states are providing the necessary instructions or performing their appropriate activities. So by breaking our program logic into specific state functions, that allows us to stay a little bit more organized. Sometimes what people like to do is they like to put this function for each state into its own tab or file. So you'll have each of the states as just a tab across the top. That's another way of working. You're certainly welcome to do it that way. It'll just break it into separate files. But you don't have to. Or you can have one long state. You may also realize that most of the states are relatively short, except for the main play state. So maybe play gets broken into its own, so your game is its own function, but everything else is in the main thing, and you could do it that way as well. Whatever it takes for you to stay organized.